So how can a function fail to be differentiable? Now we saw that the function y equals the absolute value of x in example 6 is not differentiable at 0, and the graph shows that its graph changes direction abruptly when x is equal to 0. Here is that graph. So you can see here that it abruptly changes. So in general, if the graph of the function has a corner, in this case here, if it has a corner or a kink in it, then the graph of f has no tangent at this point, and f is not differentiable there. So when we were trying to compute f prime of a, we found that the left and the right limits were different. Okay, now Theorem 4 gives another way for a function not to have a derivative. It says that if f is not continuous at a, then f is not differentiable at a. So at any discontinuity, so for instance, a jump discontinuity, the function f fails to be differentiable. A third possibility is that the curve has a vertical tangent line, when, that is, f is continuous at and the limit as x approaches a of the absolute value of the derivative is equal to infinity. So this means the tangent lines become steeper and steeper as x is approaching a. So the figure to the right over here shows one way that this can actually happen. So we can see here that this graph, you can see the tangents as it is approaching a from x becomes steeper and steeper, and then it creates a vertical line. Okay, and that means it's also here on this third graph. This third graph represents a vertical tangent. Now, the graph below illustrates the other possibilities that we have discussed. We know that if we have a corner, we have a discontinuity where it jumps, and then also we have a vertical tangent.